Good morning, students. In last class, we discussed about various pre-processing techniques. Among the pre-processing techniques, we discussed almost all what we call as data cleaning technique. So, in the data cleaning technique, we use two methods for how you clean the data, called as how you noise the data, how you identify the missing data. So, we have various scenarios for missing the data and how to handle the missing data, and various scenarios for how we handle if the data consists of noisy. And coming to this session, we are going to discuss second pre-processing method called as data integration. So in this data integration, already we discussed we have to collaborate, we have to combine, and we have to combine all various data from multiple resources like flat files and databases and data warehouses, and so that into a single database called as large database called as data warehouse, right? So whatever we discussed, we have to collect data from various repositories. That the repositories can be called as like the flat files, text files, or another databases and data warehouse. These are comes into various repositories. Now we gather all the data from various repositories and we have to store in a single data storage that is called as a data warehouse. So we have to, when we store the various data. We store the data into single format from various databases. Then we have a major issues that are to be considered during data integration. Now the main problem is our main task is to identify various repositories into one particular database. Those are entity identification problem. Already we discussed that identity identification problem in databases, that is sometimes we have a customer ID in one database and customer number in another refer to the same entity. We are merging two databases into one data from various repositories into one data warehouse, right? So in one database, so the attribute name is customer ID. Another database, the attribute name is customer number. But the same data lies in two attributes. Now you have to identify the particular entity where we have to duplicate and where we have to store and where we have to remove. Okay, so data analyst or computer decides whether they both refer to the same entity by examining the metadata of data warehouse. Now the main task here is either computer or the particular data analyst or decides which has to take from the various repositories whether it is to have the same data or not, with the by means of a one fantastic feature called as metadata. Metadata refers to data about data which lies in data warehouse, right? Metadata is data about the data. Such metadata can be used to avoid errors in schema integration based upon metadata. For example, now you can ask, what do you mean metadata? See, already I discussed that metadata in database, but in order to identify metadata, if we consider example called as college library. In college library, if there is a 2-1 textbooks, all the particular 2-1 textbooks are available in that only. So if you ask database subject, if the database consists of 2-1 and 3-1 means 2-1 data lies in 2-1 metadata structure and 3-1 lies in 3-1 metadata structure. Okay. If the database, if you are taking 2-1 data with two databases means, or two textbooks means with same features, then we have to remove one thing. Otherwise, if there is a two databases with 2-1 and 3-1 means both are different data, so that we have to consider these two textbooks. Like that, based upon the metadata, you can identify whether there is a particular entities have the same features or not. Okay. Next one is redundancy. It is another important issue in data integration. So already you know that attribute such as maybe redundant if it can be derived from another attribute or set of attributes. If you are deriving a particular attribute from the previous or the super database, you are deriving data from super data to child data, then there should be some problem called as redundancy. So whether you have to identify whether there is a some redundant data or not. And third one is these, when there is a redundancy, you have a particular schema called as correlation analysis. Based upon this particular feature, you can identify whether there is a redundant data or not. So given two attributes, such analysis can measure how strongly one attribute implies the other based on the valid data, available data. For nominal data, we use chi-square, and for categorical data, we can easily identify. Okay, so for data integration, we have two problems, two features called as entity identification problem and a redundancy problem. So entity identification should not have any particular information, just but we have some information regarding based upon the metadata. You have to write the metadata information, right? Now, how you calculate correlation text for a nominal data? Okay, how you can calculate for correlation text for nominal data. Nominal data means already you know that you have a particular what we call as nominal and categorical data. Nominal data can be calculated with the help of with the important features called as like this. So for the nominal data, a correlation relationship between two attributes A and B can be discovered by a chi-square test. Suppose A has some distinct features, namely A1, A2, so on, AC. B has R distinct values, namely B1 and B2. So I am taking two attributes which has some data. A has A1, A2 attributes, and B1 has B2, B1, B2, so on attributes. Now you are identifying whether these two attributes have the same data or not. Okay. The data tuples described by A and B can be shown in a continuous table. This is a continuous table with the C values of A making up the columns, and this is the C values. I have A values, and this is the C values of the columns, and R values of B making up the rows. Now this is the B values and this is the C values. Okay. See, this is the C values and this is the R values. Okay. By combining columns, you get a C values. By combining tuples, you get a R values. Okay. So the chi-square value already is also called as percentage statistics, is also computed by Oj sigma I is equal to 1 to C, sigma j equal to 1 to R. These are the attributes. These are the tuples. Oj minus Eij whole square by Eij, where Oj is a observed frequency and Eij is a what we call as expected frequencies. See, where Oj is the observed frequency, that is the actual count. When you are combining, you get a particular value that is called as actual count of the joint event A, Bj, and Eij is the expected frequency of A, Bj, which can be, now you have to calculate Eij with the count A equal to A into count 2, B equal to Bi into A. How you calculate this count means with the what we call as count of A. Count of A means like this into count of B means this is a count of A and this is count of B. Okay. A will get from C count, B get from the R count. Okay. Where n is the number of tuples, total number of tuples n equal to, we have combination of this is the tuples. Okay. I have particular rows like this. I have particular column like this. By combining these rows, we get, by combining columns, we get same data. We have to get same data. Okay. And then is the number of tuple, data tuples count A equal to I is the number of tuples having value of AI for A, and count B equal to Bj is the number of tuples having value Bj for B. Now see, if you are calculating this one, this E11 you are calculating. This is a 2 by 2 matrix with 1 1 1 2 and 2 1 2 2. So now you are calculating expected value, expected frequency value with this particular equation. So that now you are calculating this expected value. How you get 90 means, see, now you are getting a particular, this is the column value, A value 300 into particular tuple total value 300 to 450 by total n equal to get 90. Similarly, now you are getting 360 means you are calculating 1200 into y 450 by 1500. Now you get a expected value 360. When you get all the observed values and all the expected values, now you have to calculate chi-square. Okay, like this. Chi-square means that is what we call as Oij means 250 minus Eij means 90. 250 minus 90 by What will be the function is EIJ, expected value, by 90. Next, here we calculate 200 into 360 by EIJ, 360. So that we calculate this value, you get 507.93. For these 2 by 2 tables, the degree of the freedom can be calculated as the particular row minus 1 into column minus 1. So that 2 minus 1 into 2 minus 1, you get 1. For 1 degree of freedom, the two value needed to reject the hypothesis set, you have to see the what we call as chi-square function values from 0 to n, so that you get to with a 1 value with 2 frequency, so that they have a hypothesis as 0.001. That hypothesis of signals values is, this is what we call as, we have a log books. Based on the log books we have to calculate this value as 10.828. Since our computed value is above this, we can reject the hypothesis. The gender and preferred reading are independent and conclude that two attributes are strongly correlated for the given group of people. So we are calculating, if we get a positive values, then we can say that it is a strongly correlated, so that there should be some redundant data. If that is not happens, means there is some duplication data will be considered. Okay, now this is a nominal data, and if you take a numeric data, you have to calculate like this: ai minus a square bar, bi minus b bar. B bar, a bar is calculated with the help of mean values. Okay, and you have to calculate sigma value, so that you have to calculate a value or b value like this. This is the function where we use to calculate numeric attributes. These are the nominal attributes with chi-square value, and this is the numeric value with mean and variance. Okay, next, this is the completion of what we call as integration. So integration, we have only one concept. That concept is a how you calculate if there is a redundant data from various data storages. It can be removed with the help of chi-square data. Okay, I think you understand the concepts. Okay, in next class we discuss about data transformation. Thank you all.